Okay, so the very last things we need to do before we are done with radicals is doing some operations with radicals and kind of looking at how those play out. And then we're going to learn this specific technique called rationalizing a denominator. That's a specific technique that is going to be very helpful to you in the future. And there's two ways we're going to do it. We're going to do it in a basic scenario, and then we're going to do it with conjugates. And you're probably thinking, conjugates? That sounds like something from a foreign language class. Well, they are in languages, of course, but in mathematics, a conjugate is something that algebraists know very well. And so we're going to learn about what a conjugate is and how we use it to rationalize a denominator. But we're going to do that at the end. We're going to start by looking at operations. When I say operations, I mean the plus, minus, multiply, divide type of operations and how those work with radicals. Okay? So generally speaking, if you have the same radicand, and notice here that I have the same radicand of 5 in these two things, I can almost look at the radical as kind of like a variable. So for example, if this instead had said negative 4x minus 2x, if I essentially just equated this x with the square root of 5, see what I'm doing there? If I just equated that with that, right, and I said negative 4x minus 2x, I know I can combine those and I get minus 6x because I'm essentially counting up these things. I'm essentially counting up my x's. And we ask, if I have negative 4 of them here and negative 2 of them here, and I'm counting those up, when I total it, I have negative 6. Well, this is the same thing. If I have negative 4 roots of 5, and I'm subtracting 2 more roots of 5, then all in all I have negative 6 roots of 5. Right? And I can't do anything with the root of 5 because 5 is prime. It's certainly not a perfect square, and it's prime, so I know that there's no factors of perfect squares that are hiding inside of it somewhere. Same thing here. Negative 3 of these plus 5 of these. If I think of this as negative 3x plus 5x, it's pretty obvious that I have 2x. But I'm just going to do this the same thing with this. Negative 3 roots of 6 plus 5 roots of 6. Think of it as multiples of that thing. I'm just totaling up how many roots of 6 that I have. If I have minus 3 of them here and I have positive 5 of them there, well then, by golly, I just have positive 2 of the roots of 6. Okay? And I know that I can't simplify that anymore because the factors of 6 are 2 and 3, and neither of those are perfect squares. So that is as far as I need to go on either of those. So if you have something that doesn't have a coefficient out front, just remember that that's a 1, just like with a minus x, minus x, if we see that, then we know that that means minus 1x, right? So 5 minus 1, this is going to give me 4 roots of 5. Yep. And even when we have multiple numbers in here, we can do the same thing. Notice here that I have this term and this term are both square roots of 3, so I can combine those as I see fit. Notice that this one cannot because it's a square root of 8, and I cannot turn it into a square root of 3 because the factorization of 8 would be 4 and 2. The 4 I can pull out, but the 2 I cannot. If I was able to factor this so that I was left over with the root of 3, I could do that and then combine this in it also. But since my radicand here can only be 4 times 2, the 2 is going to be left over in the radicand, and that's not going to work with these radicands of 3. So let's see what I can do here. I'll do this one step at a time. Okay, I've got negative 3 square roots of 8. And then here I've got minus 3 and plus 3 of those square roots of 3. So that's going to be 0 square roots of 3, which just then goes away, right? So I don't even need to write that down because I know that it... What the heck's happening with that? I know that it doesn't do anything. I got a piece of whiteout tape that has thrown me off here. Let me put this in the trash can. Okay. So, sorry about that. So we can continue on here by looking at this root of 8 because I know that that's 4 times 2, so the 4 can come out and leave me with that. Okay? If you need some review on that, just go back and look at the radical notes. I really encourage you to look at the radical notes. I mean, the ones that look like this that I have typed up that are written for you on the website. So please look at that. This is what we're talking about today. I'm just pulling this right out of these notes, rationalizing and conjugates and so forth. So that's all on the website for you. Okay? And so let's look at this now. So there's my answer. Here I've got 2 roots of 10. Noticing my factors in the root of 10. Factors of 10 are going to be 5 and 2. Neither of those are perfect squares, so I have no way of simplifying that, but I can simplify this square root of 8. So let's go ahead and combine those two, which will give me 2 square roots of 10. And then I'm going to have 2 square roots of 8, but I can then simplify that into that. The 4 will come out. That'll come out as a 2 times this 2 gives me a 4 right there when this comes out. Okay? And so that is as far as I can go there. Oops, excuse me, I'm stuck on papers here. Now let's look at some, so that's adding and subtracting, okay? Now let's look at some multiplying. Remember, with the product rule, you can combine the radicands, but that's not always going to be the best thing. I can just jump right into this and go, oh yeah, that's square root of 48, you know, and then I can look at, well, what does this divide by? Does it divide by 4, etc., etc.? That's probably not the best way to do this. The best way to do this is, since this is already broken down, these numbers are smaller than the 48, and it's easier to see what your perfect square factors are in there. So here I have a 2 and a 3, here I have a 2 and a 4, but what I'm noticing is, look at this. So essentially this is the square root of 6 times 8, right? I can do that, but resisting the temptation to turn this into a 48. And again, this is a small number, so you may be able to see this, but I'm teaching you this technique in case numbers are larger. So let's split this up, because I see a 2 and a 3 and a 2 and a 4. Obviously that 4 will come out, but so will that one. Do you see that 4 there? So we can actually double up our impact here. So this is essentially the square root of 4 times 4 times 3. This will come out as a 4, and so I'm left with a 4 root of 3. 4 times the square root of 3. Okay. Here we're going to multiply radicands, leave the negative 3 in the front, and we have a square root of 12, but that's going to be 4 times 3. The 4 comes out as a 2. Right, so this is minus 6 roots of 3. Here we're going to again multiply the radicands, but square root of 3. So notice that this is 3 square root of 3 square root of 3, just using the commutative property. This is 3 square root of 3 squared. Well, the square root of 3 squared is just 3, so this is just 9. Okay, this will be the same as up there with the 6 and the 2 under it. Same process. Here we're going to distribute. Now when you distribute, you're multiplying coefficients, and then you're multiplying radicands just like you would if it was coefficients and variables. So this is another example of when the radicals kind of function like, they behave like, this is very loosey-goosey terminology, by the way, but they behave like variables in this type of arithmetic sense. So when we multiply the 4 square roots of 3 to this first term, 2 square roots of 6, we're going to have 8 square roots of 18. And then when we multiply it to the square root of 2, we're going to have 4 roots of 6. Now, my recommendation here is if you're distributing this stuff, don't try to do some kind of fancy dissection in your head and figure out ahead of the time, oh, I can, get these radicands to work like I want them to. My recommendation is don't set yourself up for a mistake, a careless mistake. Just do the distribution, and then now that you're here, this is a lot cleaner to look at, and you can figure it out from here. Because the perfect square factors are going to be there regardless anyway. So I say minimize your chances of making something a silly or careless mistake, and then just do the same work regardless. So this is 9 times 2, of course. And of course with the 6 here we can't do anything with that. So the 9 is going to come out as a 3. And we'll be left with that. Okay. Same kind of a thing here. That's going to give us 5 square roots of 3 minus 2 square roots of 18. And here we've got the same square root of 18 situation that we had before, so that would be just like over here. Okay. I'm not going to show you that one again. Now things become a little bit more interesting, as they tend to in mathematics. They become a little bit more interesting when you are, yes indeed, when you are foiling stuff like this. So we're just going to take our time and go through a couple of these examples, alright? So if I do the first, square root of 5 times the square root of 5 is going to be square root of 5 squared, which is just going to be 5, but let's just walk through the steps. Outer is going to give me this, inner is going to give me this, and last is going to give me that. So notice here I've got 5 minus 7 square roots of 5 plus 10. Combining this, and I'm going to have 15 minus 7 square roots of 5. Okay, 15 minus 7 square roots of 5. And here, if we do first, I'm going to have a positive 2 root of 10. Outer is going to give me positive root of 15. Inner is going to give me minus 2 root of 6. And last is going to give me minus square root of 3 squared. Okay, stop the video right now if you want to. You don't have to, and just make sure that you agree with all of that. And now that you've restarted the video, let's go ahead and move forward here. So we have 2 root of 10 plus a root of 15 minus 2 roots of 6 minus, now don't get caught up with this signage here, square root of 3 squared is, that's equal to 3. So this is going to be minus a 3. Okay. Now we can't simplify any of this because again, what are my factors here? 2 and 5, none of those are going to work. 5 and 3, none of those are going to work. 2 and 3, none of those are going to work. So I have nothing in here that I need to simplify anymore. So that's going to be my answer. Now we have introduced some variables in here, and I want to just remind you that variables, we can treat these just like we've been treating everything else. Using the product rule for square roots, we can actually go ahead and combine some things that we can combine here. But notice that right out of the bat, I have this 25 that can come out. So I'm just going to, well, you know what? Let's just write this all as one big radicand, and I'm going to show you it. So all I've done is I've taken the negative 5 out here. I'm just using the product rule, and I'm going to have 15 times x times 25 times x cubed. Okay, so that's what I've got. Now what's going to come out of there? Well, the 25 is going to come out for sure, but notice here that I have an x to the fourth, and x to the fourth will come out as x squared, right? So let's write that again. Negative 5 root of 15 times 25 times x to the fourth. There's no point in multiplying the 15 and the 25 because the 25 will already come out. I know the 15 won't because its only factors are 5 and 3. None of those are perfect. So this is going to come out as a 5, and this is going to come out as an x squared. So now we have negative 5 times x squared, and then what's left under the radical is just the 15. So when we simplify this, we're going to have minus 25 x squared and then the root of 15. Oops. Excuse me with that. My pen got caught. So there. Okay. Let's do another one with some some variables here. So nothing obviously is coming out yet, 8 and 6, even though we did have that 8 and 6 earlier. So let's just go ahead and put all of this together since we have a lot going on here. V cubed, 6, and V. So that's going to be 48, V fourth. So the V to the fourth will come out, but I also know here that this is that the 48 is going to be, like we saw earlier, is 16 times 3 times V to the fourth. So this is going to come out as a V squared, and this is going to come out as a 4. So that's going to be 2 times 4 is 8, V squared. What's left over is just a 3. Okay? So let's look at something new. So that's all the operations we're going to do. I'm now going to teach you how to do something called rationalizing the denominator. So I want you to put a note on this in your notes. Okay. So this is where we're going to do this thing called rationalizing. Can't seem to write today. The denominator. Okay. Rationalizing the denominator. And rationalizing comes from the sets of numbers, the rational set of numbers. Those are numbers that you can write as a fraction. But what we're getting at here is that a square root of a non-perfect square, such as square root of 3 or square root of 5 or square root of 7, these things that are not perfect squares, those are irrational. They're irrational numbers. Similarly, so is pi, so things like that. Pi, and there's plenty of other stuff. So those are irrational. Those numbers cannot be written as a fraction no matter how hard you try. These are decimals that go forever, that never repeat, that never stop. And so the problem with that is that dividing by that type of thing, dividing by an irrational number, leaves us with some difficulties, some arithmetic difficulties in things. And so it's general convention to not leave radicals in the denominator for that reason, because it's just kind of mathematically sloppy. So for the purposes of Algebra 1, I'm going to teach you how to get rid of those denominators that have radicals in them. And I'm going to expect you to do this through most of your classes that you have with me, and certainly other teachers in the future are going to have you do this as well. So this is a good technique to learn. The theory behind it is this. We learned very early on that in algebra, when we were talking about manipulating equations, that multiplying by 1 does not do anything to it, right? So a way to get rid of a square root is to multiply it by itself, because then you have that square root squared. Does that make sense? So if I had, like, the square root of 3, if I multiplied it by the square root of 3 by itself, then that's square root of 3 squared, and the square and the square root cancel, and I just have 3. So the trick is to multiply it by itself, okay? So that's what we're going to do here. But we can't just multiply this by the square root of 10, because then that would be changing this value. But we can multiply it by the square root of 10 over the square root of 10, because if you look, what does that equal right there? That equals 1, because it's just anything divided by itself is 1. So this is the technique for rationalizing a denominator. You take the radical you want to get rid of, you multiply it by itself, but you turn it into a fraction of itself over itself so that what you're multiplying by is equal to 1, and it's not actually changing the value, because this is notice this is not an expression, it's a number, right? That's a number. So if I multiplied it by something not equal to 1, I'm changing the value of the number. We can't do that mathematically. That's illegal. So by multiplying by something that is effectively equal to 1, we can get around that and still get rid of our radical in the denominator. So in the top we're going to have square root of 20, and look what's going to happen on the bottom. We have the 2, and then the square root of 10 is going to be squared, which will take care of itself, right? So we have square root of 20 over 2 times 10, right? So this is square root of 20 over 20, and if you notice at the top here, we can pull a 4 out of there because this is square root of 4 times 5. So I can pull out the 2 square root of 5, and then the 2 and the 20 cancel, and that's going to give me square root of 5 over 10. And so that's where I want you to go with that, is to get to square root of 5 over 10. Okay? And so let's do another example of that. These are all the same type of thing, but I want to give you some more experience with this. We're now going to use something called a conjugate. So let's look at number 22 here. So notice here, or even down here. Well, actually, let's just do this one. So notice in the bottom here, I have a radical, but now I have this whole group. Remember how, because of order of operations, this is like locked in down there? So I can't just multiply by the square root of 2, because if I just multiplied that, let's just do a thought experiment. This is a side. You don't have to include this in your notes. Let's just say I wanted to multiply this by, use our trick we just learned, and just do the square root of 2 over the square root of 2, right? So what's going to happen here? Well, that's in parentheses, so I'm going to end up having to distribute that to that and that to that. So the top is going to give me this. The bottom is going to give me 3 square roots of 2 minus 3 square root of 2 squared. So here, that has taken care of my square root, but then I created another problem there. So I haven't actually solved my issue at all. I've just moved it from one term to the next. So the way that we get around that is we use something called a conjugate. And the conjugate here, there are many types of conjugates in mathematics, but this is a radical conjugate. And so what we do here is we just multiply. We're still going to do our little trick here, where we're multiplying by something divided by something else. So the trick is we take the thing, I should have done this in black. We take the thing in the denominator and we just write it again, but this time we put a positive sign in there. So we flip the middle sign here. Notice that was negative, now it's positive. And so that we can still do our trick, we just do the same thing on the top. And so now, notice that even still, that thing equals 1, so we're still good to go, right? So all we've done here is we've written the same terms, 3 and 3 square roots of 2, but we've changed it from negative to positive here. And what that's going to do is, if you remember back to our quadratic studies last unit, this is a product of a sum and a difference. And when you have a product of a sum and a difference, what happens to the middle terms? They both vanish. The middle terms vanish. And those middle terms are going to be the ones that have the radicals in them. So you'll end up with radicals, but then they vanish. They annihilate each other. They vanish. And the only one you're going to be left with is the radical squared, which, as we've seen before, goes away. So let's watch how this is going to actually play out here. Okay, don't forget this is a negative sign out front. I'm just going to, for the sake of clarity, I'm just going to lump this in. Well, never mind. Just forget that I said that. So never mind. So here we have what have we got? We've got a 2 and we've got a 3 plus 3 square root of 2 on the top. On the bottom, we've got 3 minus 3 square root of 2, and our 3 plus 3 square root of 2 on the bottom. Okay, so on the top we're going to distribute. I'm just distributing there and there. And on the bottom I'm going to FOIL. So you have to FOIL those. So what do we have now? So I'm going to have 6 plus 6 roots of 2. On the bottom I'm going to have 9 minus 9 square roots of 2 plus 9 square roots of 2 minus 9 square root of 2 squared. And so if you notice here, look, we've got the middle two terms, vanish. Yay, they vanish. And here we can deal with that, right? Because that's just a square root squared, so it's going to behave like we've seen happen before. So now what do we have? We have on the top, we still have 6 plus 6 square roots of 2. On the bottom, we're going to have 9 minus 9 times 2. The square root of 2 squared is just 2. So on the top here, we're going to have 6 plus 6 square roots of 2. And on the bottom, this is 9 minus 18, which is just going to be a negative 9. And so I've got this negative and this negative I can just absorb, right? I can just absorb them. But I also want to keep in mind that I have more stuff that I can do here. So let's be algebra specialists, and let's look and see what we can do, because I see some things that'll cancel right here. Okay, so this is going to be, let me just move this over just a little bit here. Okay, so this is where I'm going to ask you to like flex all of your algebra muscles that you've learned this year. So negative, excuse me, this is negative. With that negative, those are going to cancel. So this is the same as saying this. But then in the top, I can pull out a 3, looking for common factors here and here. I can pull out a 3, and that's going to leave me with a 2 plus 2 square root of 2, and on the bottom 9, and then that's going to cancel there and leave me with a 3 in the bottom. So here I'm left with 2 plus 2 square roots of 2 over 3, and there's my solution. So I know that was a little involved. We're going to do one more example, and I can barely come in under my 30-minute self-imposed time limit. Okay, so let's do one more here. So let's do one more. Okay, so let's do number 26. It's got a negative in it. Okay, let's do number 26. So my conjugate here, I need conjugates. My conjugate here is going to be 4 root of 3 plus root of 2, 4 root of 3 plus root of 2. And so this is going to give me minus. The top's going to be 5, 4 root of 3. Let me shore up here. Root of 2. The bottom is going to be 4 root of 3 minus root of 2. 4 root of 3 plus root of 2. 20 root of 3 plus 5 root of 2. Bottom is going to be 16 square root of 3 squared. Outer is going to be 4 square root of 6 with 3 and the 2. Inner is going to be minus 4 root of 6. They vanish. And last is going to be minus square root of 2 squared. So again, notice the middle terms vanish, And then here I've just got a square root squared and a square root squared. So my goal has been accomplished. Okay, and so and I'm just, to make this easier, I'm just going to absorb this into the top and make this a minus 20 square root of 3 minus 5 square root of 2. Okay, just to get rid of that. On the bottom, I'm going to have 16 times 3 minus 4 16 times 3 minus minus 2, excuse me, I was just looking at the numbers wrong. Square root of 2 squared, this equals 2. This does not equal 4, my bad. This equals 2, so this is going to be minus 2. Yeah, because I get a 46. So anyway, so here I'm going to have minus 20 roots of 3 minus 5 square roots of 2. So that's 48 minus 2 is 46. As crazy as it looks, that's my answer. I know it's my answer because I can't simplify this. 5 is prime, so the only thing I can pull out, I could factor out a 5 from the 20 and the 5 right there, but that's not going to divide 46 because 5 doesn't divide 46. So I know that I have nothing to factor out. I can't simplify the radicands anymore. 3 is prime and not a perfect square. 2 is prime, not a perfect square. So, believe it or not, I'm done.